So in this video, we're going to look at how we find the distance between a point and a line. So we're going to act like we don't have a graph, but I'm going to use a graph to help us visualize what's actually going on. And the numbers we use are quite nice, but usually in these questions we do have fractions. So we need to work out the distance between the line P and the point 1, 1. So if I do this on a graph, the line is y equals 2x plus 4. And it wants me to find the distance from the point 1, 1. But then we could think, what distance? What part of the pink line are we trying to work out the distance from? So when we're looking for the distance, we're going to find the shortest distance. So the shortest distance from this point to this line. To be able to do that, it's going to be the line that is perpendicular that meets the point and the line. So I need to work out the distance between this point and this point. First thing we need to think about is, how do you work out the distance? By using the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. And that's how you work out the distance. We need two ordered pairs to do this. We need one of them, which we have, which is 1 and 1. And then we need this one here, where the pink and the orange line intersect. But we're going to assume we don't have the graph in front of us. But we know that we have to work out where the pink and the orange line intersect. So that means there's one ordered pair that would lie on both the orange and the pink line. So I need to do either systems of linear equations or simultaneous equations with these two lines. But to be able to do that, I need to know what both lines are. So I have y equals 2x plus 4, but I need to work out the orange line. Well, I know the orange line is perpendicular, so I know that my slope is going to be perpendicular, which is going to be negative 1 over 2x. And I know a point that is definitely on the line, which is 1 and 1. So I'm going to substitute in 1 equals a negative a half x, negative a half 1, sorry, plus b. So 1 equals negative a half plus b. If I add the half to both sides, I'm going to have 1 and a half, which I'm going to write as 3 over 2 equals b. So my equation is y equals negative a half x plus 3 over 2. So what I need to do now with this equation and this equation is work out where they two intersect. So what we're going to do now is I'm going to have y equals 2x plus 4 and y equals negative 1 over 2x plus 3 over 2. What I am going to do is, though, just because now I need to do systems of linear equations, I either need to make them equal each other or I can use the elimination. I'm going to use elimination. I'm going to subtract them from each other. But to be able to subtract them nicely, because we're dealing with fractions, I'm going to change the 2. So it's 2 over 1. And I'm going to change it so the denominator is also 2. So I'm going to change the 2 to 4 over 2. And I'm going to change the 4, so it's 8 over 2. So I'm going to change this completely. So I'm going to rewrite my equation now. So I'm going to have y equals, I'm going to start again. So y equals 4 over 2x plus 8 over 2. And y equals negative 1 over 2x. And then we have plus 3 over 2. So I'm going to subtract them from each other. So y minus y is 0. 4 over 2 minus negative 1 over 2 will change to a plus. That becomes 5 over 2 x. And then 8 over 2 minus 3 over 2 is going to become 5 over 2. Then I'm going to bring this to the opposite side. So I'm going to have negative 5 over 2 equals 5 over 2x. If I multiply both sides by the multiplicative inverse to solve what that is, I can clearly see that x is negative 1. Now that I know what x is, I can work out what y is. So I'm going to substitute it into this here. So I'm going to do. So what we're going to do now then is to work out what y is. I'm going to put this into this equation. So y equals 2 times negative 1 plus 4. So y equals negative 2 plus 4. So y is going to equal 2. And that is the ordered pair where these now intersect. When x is negative 1, y is 2, which you can clearly see from the graph. But again, we're just doing it as if we don't have a graph because sometimes you will have fractions, etc. So now I know my 2 points. I have 1 and 1 and negative 1 and 2. I can put this into the distance formula. Okay, so we're going to have the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to put my 2 points in. So we have 1 and 1, so I'm going to call this x1, y1. And then I'm going to call my other point, which I know is negative 1 and 2. It's going to be x2, y2. So the square root of 1 minus negative 1 squared plus 2 minus 1 squared, which then 2 negatives make a positive, so this is going to become 2 squared plus 2 minus 1 is going to be 1 squared. And then we have 4 plus 1, and then my answer is the square root of 5. And I can leave it like this, or I can actually work out what the square root of 5 is, which is going to give me a long decimal, but I could write an estimation of around 2 point, and if I do it to 1 decimal, it's 2.2. And that is the distance between these 2 points, so a point and a line. What we're going to do in the next question then is have a look at when we have 2 parallel lines and we have to work out the distance between them. Okay, so we have 2 lines, we have a pink and we have a blue. And we need to work out the distance between them, but again, the distance between what? Do I just draw a random line and try and work out the distance? No, we're going to try and work out the shortest distance, which is perpendicular. Because when we have parallel lines, the distance is the same between. That means the perpendicular line is the same in between. So to make this a little bit easier, we have to decide on which line we're going to start from and a point, an ordered pair. So pick something we definitely know. So in this question, I'm going to pick something I definitely know, which is this point here. I definitely know my y-intercept is going to be x negative 1. And I'm going to put that into the problem we've just done in the last one, because it's going to be exactly the same. So I need to work out the distance from the blue line to the pink line, but from this point. So I'm going to do the perpendicular line from that point, which in this case is the green line. Okay, but again, we're going to assume we don't have the graph. And I'm going to try and make out the point where the green and the pink intersect. Okay, so I need to work out the equation of the green line, and then I have to try and do the elimination method to eliminate them. So, first thing I know, is that they're perpendicular. So y equals negative 1 over 2x plus c. I know the point 0, negative 1 is definitely on that green line. So if I put negative 1 equals negative 1 over 2 times 0 plus c, well, they have the same y-intercept anyway. So, but if I still solve it, I know negative 1 equals c. So my equation is going to be y equals negative 1 over 2x, and then it's going to be plus, it's going to be minus 1. And that is the equation of my green line. Okay, so now what I need to do with the pink line, which is y equals 2x plus 4, and the green line, which is y equals negative a half x minus 1, I need to do systems of linear equations to see where they intersect. So in order to do that, I'm going to write it over here. So y equals 2x plus 4, and y equals negative 1 over 2x minus 1. I'm going to do the same as what I did with the last question, but I'm only going to write the slope as a fraction, just because the perpendicular line is only as a fraction the slope. So 2 over 1 becomes 4 over 2. So I'm going to rewrite this and write y equals 4 over 2 x plus 4, y equals negative 1 over 2x minus 1. I'm going to subtract them. So I'm going to have 0 equals 4 over 2 minus negative a half becomes 5 over 2x. And then 4 minus negative 1 again becomes a plus. That's going to become 5. So that means negative 5 equals 5 over 2x. If I multiply both sides by 2 over 5 and 2 over 5, we're going to have here that 2 times 5 is 10, divided by 5, it's going to be negative 2 equals x. Now that I know what the x is, I can just substitute that in to find out what y is. So y equals 2 times negative 2 plus 4. So 2 times negative 2 is negative 4 plus 4, y equals 0. And that is the second point I need to work out. So when x is negative 2, y is 0, which you can clearly see it is, but we had to prove it if we didn't have a graph. So now that I have my 2 points in question, I have 0, negative 1, and I have negative 2 and 0, I can put them into the distance formula. So again, distance formula is x2 minus x1 squared plus y2 minus y1 squared. And I know my 2 points. It's negative 2 and 0, and it is 0, negative 1. So if I put them in, I'm going to say this one is my x2. So 0 minus negative 2 squared plus negative 1 minus 0 squared. This is going to just become 2 squared plus negative 1 squared, 4 plus 1, and it's the same as the last question, which is the square root of 5. And that's how you work out the distance between two parallel lines. You have to make sure you're looking for the perpendicular line that connects them together.